Watson is a network of scientists and stakeholders who share their knowledge on water fluxes in the critical zone. What is the critical zone? The critical zone is the skin of the Earth, extending from the top of the vegetation canopy through the soil down to groundwater. It is the place where atmosphere, water, living beings, soil and rock interact. Water takes part in all physical, chemical and biological processes in the critical zone. These processes can be quite complex to study, since many factors such as the type of rock, soil, vegetation and climate affect them. For this reason, Watson brings together experts from many different disciplines to compare and synthesize current specific knowledge and to develop the research agenda for years to come. Watson focuses on three main water pathways through the critical zone. The flow of water from the surface through the soil and to the groundwater, the flow of water absorbed by plants from the soil and given back to the atmosphere as vapor, and the paths followed by water to travel from the atmosphere to the streams. Why are we interested in these water fluxes? Watson aims to have a significant impact on people, communities and the environment, to support society to face challenges such as how to make better use of the available water resources in agriculture, how to predict and mitigate the effects of climate change on water supply, and how to prevent water shortage due to droughts or water excess due to heavy rainfall. How do Watson members study water fluxes? The work of Watson is based on the analysis of stable isotopes in water. Each water molecule is made of 2 atoms of hydrogen and 1 atom of oxygen. There are 2 stable isotopes of hydrogen and 3 stable isotopes of oxygen. Because isotopes of the same element contain different numbers of neutrons, each of the different forms of water molecule has a slightly different mass. In a given volume of water, there are many molecules whose mass is determined by the combination of the different oxygen and hydrogen isotopes. The relative number of these different isotopes is a fingerprint of the water and gives clues that scientists can use to understand where that water comes from and which processes it has undergone. So this means that each water has its own signature. So for example, using these water isotope signatures, it is possible to determine the age of stream flow or groundwater, or from which soil depth the plants absorb water, whether they absorb mainly summer or winter rainfall, or if the plant water mainly comes from irrigation. Watson is a cost action, a program of the European Union to promote European cooperation in science and technology. Cost actions promote collaboration between and among researchers, students, water managers and governmental organizations. By organizing meetings and workshops. By bringing people together, Watson aims to synthesize information on best practices for sample collection and data analysis, to provide guidelines for the application of stable isotope analysis to address societal issues, and to create a database of existing studies. Watson also provides grants for participants to visit other institutes in the network, to attend conferences, or to publish their findings. If you're interested in learning more about our activities, visit our website or follow us on social media.